Good day, students. Welcome to part 4 of the Integrated Algebra Regents review for January 2014. In this installment, we are going to be going over problems 16 through 20. You can gain access to other clips at mathconcept.com/testprep. You can also gain access to the release documents that I'm working on. Let's go ahead and take a look at question number 16. So for problem 16, we're asked, what is the vertex of the graph of the equation y equals 3x squared plus 6x plus 1? There are two ways for us to find the vertex. One of the methods involves completing the square, and the other involves using the vertex formulas. Okay, so I'm going to use the quicker of the two methods, which is basically using the formula for the x-coordinate of the vertex and substituting it in to find the y-coordinate of the vertex. All right, so the vertex is basically a set of coordinates. Let's write down what they are. So we have our vertex. A vertex is made up of an ordered pair. We have the x-coordinate of the vertex, and we have the y-coordinate of the vertex. Okay? To determine the x-coordinate of the vertex, you simply compute negative b over 2a. Okay? And then if you want to find the y-coordinate of your vertex, you're going to evaluate the function at that x value. Evaluate the function at negative b over 2a. So what this expression here means is you find negative b over 2a and plug it into your x values of your function, and that will give you the y-coordinate of the vertex. Okay? So in order for us to make use of this formula, we have to first of all write down our function. In this form, 3x squared plus 6x plus 1. Okay? And then let's determine what a and b are, because they are the terms that determine the coordinates of our vertex. So we can clearly see here, this is a, b, and c. Okay? Make sure that the function is written in standard form, the degree is written in descending order of magnitude of the powers. Okay? So a is 3, and b is 6. Okay, now we're going to go ahead and find the x-coordinate of our vertex. The x-coordinate of the vertex is determined here by computing negative b over 2a. So all we're going to do is plug in these two values into negative b over 2a and calculate what the x-coordinate of our vertex is. Okay, so let's go ahead and compute that. Negative 6 over 2 times 3. So that yields negative 6 over 6. So negative 6 over 6 is equal to negative 1. So that's the x-coordinate of our vertex. Now let's go ahead and compute the y-coordinate of our vertex. I'm going to divvy up my workspace. Put a line there to avoid confusion. So to determine the y-coordinate of our vertex, we're going to evaluate the value of this expression f of negative b over 2a. Now what on earth does this mean? This simply means you plug in negative b over 2a into the x's of the function. Okay? Because if you have y equals 3x squared plus 6x plus 1, another way of writing the function is f of x is equal to 3x squared plus 6x plus 1. So whatever the input is, you square and multiply by 3 plus that input times 6 plus 1. Okay? So f of negative b over 2a is the same thing as f of, let me change the color, negative 1. All right? So where did that negative 1 come from? That is the x-coordinate of a vertex we got in the first part. So this simply means we're going to take all the x's in the function and replace them with negative 1. So that's going to look like this: 3 times negative 1 square, okay, plus 6 times negative 1 plus 1. Then we'll simplify this using order of operations. Negative 1 squared, you have to be really careful. When you're squaring a negative number, it turns into positive, because negative times negative is positive. So 3 times, this becomes 3 times positive 1, plus 6 times negative 1, minus times a plus is minus, minus 6 plus 1. Okay? And then this becomes 3 minus 6 plus 1. 3 minus 6 is negative 3. Negative 3 plus 1 is negative 2. So that goes the y-coordinate of our vertex. So our vertex is going to be the x-coordinate, which is negative 1, and the y-coordinate, which is negative 2. So we can clearly see that our solution is option number 1. All right, let's take a look at problem 17. It says the length and the width of a rectangle are 48 inches and 40 inches. To the nearest inch, what is the length of its diagonal? So in problems like this, where measures of a shape are provided, it's always good to make a sketch of the situation, label fully, and use the relevant formula to connect the situation with a mathematical equation. All right, so the shape here is a rectangle. Let's go ahead and just draw an arbitrary rectangle. And we know that a rectangle has the length and the width. So let's call this L and W. Okay, and do you know what the diagonal is? The diagonal is the segment that connects opposite vertices of a rectangle. So this rectangle has two diagonals. Let's use this diagonal right here, and let's call that D. Okay, so what are our variables? We have the length. The length is L, which we know the measure as being, let's see, the length is 48. Notice here it says length, 48. And then the width is given by W, and we also know what the width is. It's 40 inches, indicated here, with 40. And then D is a diagonal, so let's call D the diagonal. You can call it whatever letter you want. I just like using the first letter of the term so that I can keep track of what I'm working on, okay? So what is the length of the diagonal here? Well, that's what we're looking for, so let's put a question mark, okay? So the question is what formula connects these three measures, okay? So if you take a look at if you divide this rectangle into two, you have a right triangle. And do you know the formula that relates to three sides of any right triangle? Let me draw a situation for you. So let's say we have a right triangle like this. Right triangle. So what formula relates the three sides? Let me give you a hint. This is A, B, and C. The formula that relates to three sides is the Pythagorean theorem. Okay? So it tells us that the sum of the square of the legs is equal to the square of the hypotenuse. Okay, so we can see that we have a square plus b square. So the sum of the square of the legs is equal to the hypotenuse square, c square. The side opposite the 90-degree angle is the hypotenuse. Okay, so if you look at this rectangular situation we have here, we can see that L and W correspond to the legs of the right triangle, and the diagonal is to C. So if we apply this Pythagorean theorem to this situation right here, this problem, we're going to have the length square plus the width square is equal to the diagonal square. So this equation that relates to three variables can help us solve for D. Okay, so let's plug in what we know and what we need. We know that the length is 48. So we have 48 square plus the width is 40 plus 40 square. Don't forget to square them. Is equal to the diagonal D square, which is what we're looking for. All right, so what we have now is an algebraic equation with one unknown, and we can basically solve it easily. Okay, so what we're going to do is how about we plug in the left side into the calculator first, and then we're going to isolate D. So I'm going to be using a TI-89 titanium to do my calculations. So we have 48 caret 2 raised to the second power plus 40 raised to the second power. Answer is 3,904. So that's the value of the diagonal square. So we have D, let's change that. We have D square equals 3,904. Now how do we get D isolated? Get D by itself. We do the opposite of the square operation, which is the square root. So you root both sides. And then you have D is equal to, let's have our calculator help us out with this computation, the square root of my previous result, 3,904, enter, 62.48. We were asked to round our solution. Let me see what we asked to do here. It says, what is the length of the diagonal to the nearest inch? So to the nearest inch, we're basically rounding it to the ones place, okay? So the number before the ones place, if it's 5 or greater, we have to round up, add 1. But if it's less than 5, we just truncate the numbers behind the ones place, okay? So the number behind the ones place, which is the tenths place, is 4. 4 is less than 5. So all we're just going to do is we're just going to drop everything after the ones place. They all become zeros, okay? So 62.48, let's write this down. This is approximately 62. Approximately 62 point, what was it again? 62.482, 482. So our diagonal is going to be 62 inches to the nearest inch. Okay, so we had to do some rounding action here to the nearest inch, which resulted in us dropping off these decimal parts of the solution. Okay, so we can clearly see that our answer is number 2. All right, let's take a look at problem number 18. We're to solve a linear inequality and graph the resulting solution. Okay, so we have 2x minus 5 is less than 3. Now, when you're solving a linear inequality, you treat it as though you're solving an equation. Okay, the only thing that's different is anytime you divide or multiply by a negative number, the inequality reverses its orientation. Okay, so now this is less than. Remember, this inequality is just like the L if you rotate it. So this is less than. And then the other one is like a G for greater. Okay, so just you have to remember your inequalities. Okay, less than and greater than. So this is less than because it's like a L. And then this is greater than because if you add that little piece to it, it looks like a G. Okay, all right, so let's solve for x here. We can do this in 2 steps. We get rid of the 5 and then the 2. So let's address the 5 first. You add 5 to both sides, and that yields 2x is less than 3 plus 5 is 8. And then we simply divide both sides by 2, positive 2. But you notice that we're dividing by a positive number, so there's no inversion or reversal of our inequality here. 2 divides 2 once. So you're going to have x is less than 4. Okay, so how do you graph this inequality? The solution region is everything less than 4. Note 4 is not included in the solution region. If you wanted to include 4 in the solution region, what would that look like? You just simply put a line here. That line underneath the inequality means inclusion. Okay, so you want to keep that point in mind. So this inequality tells us that any number that's less than 4, that's to the left, the points to the left of 4, excluding 4 will be our solution region. So if we wanted to graph this on a number line, let's go ahead and graph that. Let's see how our number line. I'll just graph 4. Let's say this is 0 right here. 0, 1, 2, 3, 4. So excluding 4, any number less than 4. So what direction are we going? We're going to the left, okay? Because going to the right is the order of increase in magnitude, but we're going less than, so we go to the left. All right, so we can clearly see that our answer is option number 1. Had it been that we had a line underneath, this circle will be closed because 4 will be included, and then our answer will be option 2. All right, so you have to be really careful to take a look at your inequality when you're graphing, okay? Because the slightest mistake could make you select the wrong answer. All right, let's take a look at problem 19. 19 says Jonathan drove to the airport to pick up his friend. A rainstorm forced him to drive at an average speed of 45 miles per hour, reaching the airport in 3 hours. He drove back home at an average speed of 55 miles per hour. How long to the nearest tenth of an hour did the trip home take him? So we can see um, here that it was necessary for him to drive slowly when he was leaving home to the airport because of the rainstorm. And I guess it must have abated the storm when he was returning because he was able to drive 10 miles per hour faster than average. Okay, so this is kind of like a physics situation. So one thing you want to note is that the distance from the airport to the house is the same regardless of the direction, right? Because the assumption here is that he followed the same path. Okay, so let's say this point right here is home. We're going from home to the airport. Airport. Yeah, airport. Okay, so let's say his outbound destination is 1. So 1 is heading out. This is when it was raining. Okay, so when it was heading out, he was driving at a rate, let's call it R1. Or well, yeah, R1 is like the rate. Okay, R1 rate and speed are the same thing. So R1 going is 45. And how long did it take him to get to his destination? Let's call that T1. He reached there in 3 hours. Okay, so going out, heading out 45 miles per hour, 3 hours, so T1 is 3. Now, T hours, 45 miles per hour. How about coming back home? Coming back home, how about we call that 2, okay? So when coming back home, he drove much faster this time. Let's call that second rate, the average speed or the rate going back home. Let's call that R2, and that's 55 miles per hour, okay? And then how about the time? How long did it take him to get back? It says, how long to the nearest tenth of an hour did the trip home take him? So that's what we're looking for, question mark. Okay? So what you want to notice is that the distance is the same. Now, I'm going to use an equation to connect the rate and the time. Do you know what equation that is? What equation relates the rate and the time of an object that's traveling? It's the dirt formula. Okay, dirt formula. What does dirt mean? Dirt basically tells you that distance is equal to rate times time. Okay, so don't forget that. That's really important, the dirt formula. So for case 1, D is equal to R1 times T1. What does this mean? It means the distance, the total distance from home to the airport is equal to the average speed times the time. Okay, so while at it, we can calculate what the distance is. Okay, so R1 is 45, and the time T1 is 3. Okay, so let's multiply 45 times 3. That's not hard, that's 135. 120 plus 15. So 135 miles is the distance. This entire distance is 135 miles. Okay? How about 2? For 2, since it's the same distance, the dirt formula being applied to the return trip is going to be R2 times T2. Okay? Now let's see if we can formulate an equation here. Do we know the distance? Absolutely. The distance we have just computed using the ones. So the distance is 135 equals R2 is 55 miles per hour. We had figured that out earlier. Notice the rate going back is 55 miles per hour. And how long did it take him? We do not know, so we'll call that T2. Okay, so we solve this resulting algebraic equation for T2. We can figure out how long it takes him to get back home. Okay, so how do we get T2 by itself? Well, we'll just simply divide both sides by 55. Divide both sides by 55. And then you have T2 is equal to, let's calculate that in our calculators. So we have 135 divided by 55. And the answer is 2.45455. 2.45455 hours. Okay? if we take a look at this situation, it makes sense that it takes him a shorter time to get back, right? Because he was driving faster, so it took him quicker to get back. Now, the question is, what is the answer to the nearest 10th? Okay, you have to be really careful here because there are two potential candidates. Is it 2 hours or 2.5? When you're rounding to the nearest 10th, okay, what you do is you're going to look at the 10th place and then look at the number behind it. If that number is 5 or greater, you add 1 to the 10th place. If it's less than 5, you just drop everything, make them zeros, and that will be your final answer. So this is the 10th place right here. So please pay close attention to your place values. This is the 10th place. That is where we're rounding to. You can put a line here. Behind the 10th place, this number is 5. So that means we're going to have to add 1. Okay? So let me take all my scratches out of there. So this is the 10th place. So in this case, we're just going to round it up. Okay, add 1. So T2 is going to be 2.5 hours to the 10th place. Okay, that's why we have it the way it is, to the 10th place. Had it been we're asked to round it to the ones place or to the nearest hour, our answer will be option number 1. But we're asked to round it to the 10th of an hour, so we have to round it to the 10th place. And we can clearly see that our solution is option number 2. All right, so that's that. All right, let's take a look at the last problem in this installment. I'm going to find what this expression is equivalent to. So we have 2n over 5 plus 3n over 2. So in order to be able to do this, sum this expression together, we need to know how to find our LCD. Okay, so what is the LCD of 5 and 2? What is the LCD of 5 and 2? What is the biggest number that both of them can go into? Since they're co-prime, they're both prime numbers, it's easy to figure them out. You just simply multiply them together, which is 10. So the lowest common divisor of 5 and 2 is 10 because this is the smallest number that these two can go into evenly. All right? So the goal is to convert the denominators into the lowest common divisor because in order for us to combine them, their denominators must be common. All right? So in order to make this in order to make this 10, we'll multiply top and bottom by 2 because 2 times 5 is 10. In order to make this 10, you multiply top and bottom by 5. Okay, so this expression now becomes 4n over 10 plus 15n over 10. All right, now what you do next is you simply add the numerators together. 4 plus 15, which is 19n, over 10. Don't multiply, because if you multiply, you get 60n squared over 100, which reduces to this, which is absolutely wrong. But when you're adding, you just add a numerator, and then you keep the denominators the same. So your answer is 19n over 10. Final answer is option number 3. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool test prep clips such as this. And do give us a thumbs up if you like this presentation. We appreciate it. Thanks again for watching. More clips can be found on mathgotserved.com/testprep. Have a wonderful day.